Okay, so here's the first practice problem of this unit, or of this learning target. A rolling ball has an initial velocity of negative 2.5 meters per second. A. If the ball has constant acceleration of 0.27 meters per second squared, what is its velocity after 4 seconds? Okay, now, let's do part A. So, part A says if the ball has constant acceleration of 0.27 meters per second squared, what is its velocity after 4 seconds? Okay, so in this case, I know negative 2.5 meters per second is my original velocity. I know that. I'm going to write that over there. 0.27 meters per second. This is my... that is my acceleration. I know that. And its velocity after 4 seconds. 4 seconds. My time. So, which equation do I use to find out this answer? Thanks to my handy dandy note card right here, I can easily find that out. So, I'll be using VF equals V0 plus AT. This is the equation I will be using in order to solve this problem. So, V0, negative 2.5, okay, so negative 2.5 plus acceleration, 0.27, okay, 0.27 times t. What's t? 4, okay, so 4.0. Cool. Now, I gotta add that, so I gotta use my calculator for this, and that is 2.5 times 2.7. So that should be, this answer should be negative 1.4 meters per second. Yes, meters per second. So, what is velocity? Yes. But we got sig figs to do. So now sig figs, okay, so let's see. So I see 0.5, okay, so I see one digit as my least number, so then my actual answer will be 1.4 meters per second. And this is my answer for A, which is negative 1.4 meters per second. Okay, now, this is part B in the problem. So part B says, how far did it travel in this time? So remember, the question states that a rolling ball has an initial velocity of negative 2.5 meters per second, right? And then now this is part B. Okay, so I wrote on the side, I wrote what the acceleration is because I have a feeling we might need it later. So the acceleration was 0.27 meters per second squared, right? Okay, so now using my equations note card again, I will now find an equation to find the answer to this solution. Okay, so how far did it travel in this time? So knowing how far, now I know that's a distance formula. So, these are t, so means I know this is the original velocity, and t, I know t was 4, so I'm going to write over here. T is 4 seconds, so right over there, and then half a t squared. So I think I'm going to use this formula. I'll use d is equal to VO plus half a t squared. This is the formula I'm going to use to solve this solution. Okay, so now I know VO, which was negative 2.5. Okay, let's write that down. So negative 2.5. Okay. Oh, sorry. Actually, negative V0t plus half a t squared. So that makes a little more sense. That did not make any sense for me at all. So I double checked it. Negative 2.5 times 4. There you go. And then plus let's just say 1/2, right? So 1/2 a, so 0.27 t squared. Okay. Okay. So now I have to first multiply this together. Let me use my handy calculator again. So I have to do negative 2.5 times 4. Okay, this is negative 10 plus 0.5 times 0.27 times 4 squared, which is also, 4 squared is obviously 16. Okay, so now let's multiply that together. So 0.5 times 0.27 times 16. Okay, I'm getting 2.16. So that is, negative 10 plus 2.16 is equal to negative 7.84 meters, right? And since we got to convert into sig figs now, okay, so then sig figs would be negative 7. Sorry, it won't be negative 7 point. This answer then would be negative So then this answer would be negative 7.8 meters. This is my answer. Okay, now, this is part C of the question. The question was, a rolling ball has an initial velocity of negative 2.5 meters per second. And as I said before, VO, the original velocity was negative 2.5. Now, C, how long will it take the ball to come to a stop? Okay, so from guessing from this, how long? So, what I have already is, I have A, which is a negative 2.7 meters per second squared. And it's saying how long, so by that, we have to figure out time. So to solve this part of the problem, I'll use my handy dandy note card again, and I will use V0 or VO, sorry, plus AT. VF equals VO plus AT. VF, we don't know yet because it's the final velocity, and since there's acceleration involved, that will change the final velocity. So this is just the initial. Okay, so guessing from this, so VO plus AT. Okay, so I don't need my note card anymore. Now I just gotta solve this. So VF. So since we don't know VF, I'll put 0 over here. So 0 equals VO, which is negative 2.5 plus 0.27 times t. Okay, so guessing from this equation will be 0 equals negative 2.5 plus 0.27 t. From this step, I'll move the negative 2.5 over here to the 0. Remember, the 0 is from the final velocity, which we obviously don't know yet. So in the end, it'll be 2.5 equals 0.27 t. So from over here now, this is like a simple algebra equation. T simply as the missing variable, the value we need to find out. Okay, so then this is simple now. So I move 0.27 to this side, which that will make it 2.5 over 0.27 equals t. Now, I have to calculate it now. So, 0.25, so 0.25 divided by 0.27, which is, I'm sorry, 2.5 divided by 0.27, which is equal to, which means t is equal to, sorry that does not look like a t, t is equal to 9.25 seconds. Okay, so using sig figs, this would be t is equal to 9.3 seconds. So this is my final answer. T is equal to 9.3 seconds. So here are the set of practice problems that I'm going to show you for this unit. This is the first question. A car is going at an initial speed of 30 meters per second and is accelerating at 5 meters per second squared. A. How much will it travel in 10 seconds? Part B. What will its velocity be 10 seconds later? Okay, now let's solve part A. So, let's see what's given in the question. So, a car is going at an initial speed of 30 meters per second. So I see 30 meters per second. So I'm going to go ahead and write VO at the top. And is accelerating at 5 meters per second squared. Okay, 5 meters per second squared. So that's the acceleration. I'm going to write that down. And the question says, how much will it travel in 10 seconds? 10 seconds, okay. So I know that's my time. And then now from all of this, now I'm going to use my handy dandy classroom note card that we're allowed to use and see which equation to see which one will fit to solve a solution. Now, I will use D equal to VOT plus half AT squared. So this is the equation that I'm going to use. Now you need to fill all this stuff in. Okay, so I know my VO, my original velocity is 30. So I'm gonna put that in right now, plug it in. So D is equal to 30 and VOT. So now what is my T? So T is 10. So I'm gonna go ahead and put 10 right here plus half, or 0.5, times A. So my A is 5 because that's my acceleration. So 5 times t squared. So my t is 10. I'm going to go ahead and put 10 there and squared. Okay, so I don't need this anymore. Now I can go ahead and start calculating. So 30 times 10, which is 300, plus 0.5 times 5 times 10 squared. 10 squared is also just 100. 5 times 100 is 500. 500 times 0.5 is 250. So 300 from 30 times 10 plus 250. Okay, now this is 300 plus 250, then this equals 550. So then my answer becomes D equals 550 meters.